Hello guys, welcome back to the channel. So in this video we are gonna solve the problem which is today's daily Leetcode problem, Leetcode daily challenge. So I haven't solved this problem yet, and I have just tried this problem on 26th of July, I think. So let's just read the problem statement and we'll just try to build the logic. I haven't thought of this, like how to solve this yet. I'm gonna solve this problem live, you can say. You may recall an array mountain. So I've read the problem a long time ago, so I have to just read the problem once again and understand what it is saying. You may recall an array, a mountain array, if it is length greater than 3. Okay, there exists some I with 0 to length minus 1, such that 0 to till I it is increasing, and from I to length minus 1 it is decreasing. Okay, given a mountain array, what is this? Mountain array. Oh, this is a class that has been defined here. Fine. Return the minimum index such that mountain dot get index dot get returns the element of the array at that particular index. Okay. Mountain array dot get index equals to target. We have to just return the minimum index such that this condition is satisfied, and if there is no such index, then return minus 1. Fine. You cannot access the mountain array directly. Okay. Submissions making more than 100 calls to the mountain dot get will be judged wrong. That is why I was getting wrong answer, because I have just implemented a brute force where I am just iterating over all the elements and checking the first element from the left, that is equals to target. That is what we have to return here. So the brute force can be just iterate over all the elements and return the first one, but that might make more than 100 calls, and this will be judged wrong as per their statement. So what else we can do here? One thing that is obvious, that the elements will be in the form of mountain. Okay, and elements are strictly increasing or not. Let me check. Okay, there can't be same element, there can't be same adjacent element, so every element is unique and strictly increasing. Okay, means basically on the from peak to left hand side all the elements will be unique. That is what I'm trying to say. So the elements will be in the form of this particular mountain. There will be some peak, like here it is 1 2 3 4 5, and after that 3 and 1. So this is what in this form the input has been given to us, and we have to just output the first index that is equals to the target. Let's suppose the target is 3 and this was not equal to 3, else it is 4, and it is 5, and this one is 6. Then in this case we have to return this index, because this is the first index where we are getting number equals to target. So what do you think what we can do in this problem? Let's first build a logic, then we will try to implement this. One thing that I can observe here is, if we have been given some target, then that particular target can be found on the left hand side. Okay, and on the so that particular target can be found only on the left hand side once, or right hand side. And since our array is strictly increasing, if I divide this in two parts, then in this part my array is increasing, and in this part array is decreasing. As you can see that here is monotonicity. So, and all the numbers are unique also. So we have, it's just a standard binary search problem, I think, where if we are dividing the array into two parts, from peak to left hand side and from peak to right hand side, then on the left hand side we have our array sorted, and we have to search for a target value. If we are getting the target on the left hand side, then we have to return the index. Otherwise we have to search for that particular target on the right hand side, because on the right hand side the array is also sorted in the decreasing order, and we also look for target in that particular search space. So I think it is just a standard binary search problem where we have to find the peak element and apply binary search on the left hand side and on the right hand side. Yeah, this is all about this problem, I think. So let's just try to implement this and see what we are getting. So for implementation purpose, first of all, what is our target? We have to find the peak value so that we can divide the array into two parts. Like the array is given in this form, we have to find this particular thing, this thing, so that we can apply binary search on the left hand side and on the right hand side. How can we do this? Let me just implement a function that will return with a peak. Find peak, and it will take mountain array as input, and in this particular thing I have to find the peak value, and also peak should be found. Also we have to find peak in less than 100 calls. In overall the call should be less than 100. So let's just first of all trying to analyze the time complexity here. Length is 10 to the power 4. So in search, first of all we have to search for peak that will take order of log n, which is almost 17 operations. Then we have to apply binary search on the left hand side, which will cost us 17 operation at max. This is approx value, and 17 values for the right hand side. So 51 calls in worst case. Okay, this will work. Yeah. So first of all I'll take left hand side equals to 0 and the right hand side equals to array dot length -1, or we are just finding peak, so just take leaving one elements on the both hand side. Now we have to apply binary search in order to search the peak element to find left is less than right. And how can I get the first of all find mid equals to left plus right minus left by 2. After that, if I'm searching for peak, then what I can do, let's suppose I want this number. So if this value is greater than this will be 3 and this will be 2, greater than this one, so we have to shift our right to mid -1, so our mid. If how can I get the value? Array dot get mid. If the mid value is greater than array dot get mid +1, then in that case we have to shift our right to mid, else we have to shift just left to mid +1. I think and return right, because that will be on the peak position. So yeah, this is the peak. We have found the peak value. Let's just check that if we are getting right or not. Int peak equals to find peak mountain array. Compilation y error length. Oh sorry, it was a spelling mistake. So we are trying to find the peak first. After that we will see what we have to do. 0 1 2 3 and 4, this is the peak. Yeah, working fine. Now what we have to do, we have to apply binary search on the left hand side. So I'll make two functions, int binary search left, which will take two arguments, mountain array array and target value. After that, we have to just apply the standard binary search in this particular range. Int left equals to 0, and actually for finding this particular thing, I will pass two values, int left range and right range. So while left is less than right, less than or equals to right, int mid equals to left plus right minus left by 2, and if our array dot get mid equals to array dot get mid, if our equals to target, since all the numbers will be unique because they are strictly increasing, so we don't have to care about that multiple threes will be there, consecutive threes. So just if you're getting the value equals to target, then just return mid. Else if array dot get mid is less than target, then what we have to do, less, if it is less, then we have to shift our left to mid plus 1, else shift right to mid minus 1. Fine, otherwise return minus 1. And one more function I'll make for to search on the right hand side, which will be similar to this, and just one change, because this will be greater, then we have to shift that particular thing, because the number will be in the reverse order on the right hand side. I hope it is clear to everyone. This is just a standard binary search on the reverse sorted array, and this is just standard binary search on the sorted array in ascending order basically. Now I have to find the peak element. Peak equals to find peak mountain array. Okay, now I have to calculate the answer for left. Int left answer equals to binary search left, which will take mountain array and target, and this will be from 0 to peak we have to search. And int right answer equals to binary search on right hand side, which will take two arguments, mountain array target and the search space range, which will be peak plus 1 to n minus 1. And what is n here? N equals to mountain array dot length. Yeah, and first of all you have to check, first of all we have to give priority to the left hand side element, because we have to return the minimum index. So if left answer does not equals to -1, then return left answer, otherwise just return the right answer. Yeah, I think I'm done with the code part. I hope I'm not getting any compilation errors. Mountain array, what is the issue? Mountain array, okay, it is mountain array. Fine, here also we have to change it, mountain array. Yeah, I hope it works, because this seems correct to me. What is the error? Binary search left. What's the issue? Redeclared. Oh, sorry. I have to change the name of the function. Okay, it is working on the samples. Let's try to submit this. Okay, nice. We got an accepted verdict here. So it was just a standard binary search problem where we have to find the peak element and divide the array into two parts, and just apply binary search on the left hand side on the ascending order sorted array and on the reverse sorted array. And this is just a standard binary search problem, guys. And the tag is although given hard, but it is not that hard if you know binary search. And the overall time complexity, the number of total calls, as I have explained, that this will take maximum 17 calls, this will take maximum 17 and maximum 17. So in total we will get, in the worst case if I consider 60 calls, because we are taking this also. In the worst case, just consider to be on the safer side, that it will make the 60 calls, and we have been given the limit as 100. So yeah, this is acceptable. Thank you guys for watching the video.